Algebra uses variables to represent unknown values in expressions and equations. If you remember from yesterday's lesson, a variable is another word for a letter. And when we know the values of those variables, then we can evaluate an expression. So today when we're looking at algebra and substitution, it's important for us to remember what the operations are within a given expression. So we're going to take a look at some differences between expressions, starting with example A. So example A has two expressions, 3 take away x and negative 2x. In the first expression, the negative sign represents subtraction. In the second example, our negative sign represents a negative number. So it shows that our negative, or 2, is negative. In the second set of terms, we have 2x and x squared. In the first term, the 2 represents multiplication. So this is the same as 2 times x, or 2 times x, whichever way you want to think about it. And the 2 in the second term represents an exponent. So in this case, it would be x times x. And lastly, when we take a look at the two terms in part C, we have 3x squared and bracket 3x close bracket squared. In the first one in part C, the squared symbol is just attached to the x. So this would be the same as 3 times x, because x squared is x times x. In the second term, because our 3x is inside of a bracket, their squared symbol is attached to the entire term. So this would mean that we would take our 3x and we would multiply it by another 3x. So it's 3x squared, or 3x times 3x. So now that you understand some of the differences between how algebra expressions are expressed, or are informing the person who is solving the question, we're going to take a look at substitution now. So when substituting into an expression, we replace the variable with a constant. Okay, so whatever that happens to be. So we're going to replace it with a number first and place the substituted value inside of the bracket. So we're replacing the variable with a constant or a number. So if you remember from yesterday's lesson, a constant is the same thing as just a single number. So let's take a look at some more examples. So we're going to substitute x equals 5 into the expressions below and then solve them. So for our first one, good practice shows us that we want to put equal signs in front of my steps to show that the expressions are equal to the original question that we're being asked to solve. So I have 2 plus 3, and because the 3 is directly beside your x, this is the same as multiplication. I can express multiplication by putting in brackets, or I can use a multiplication symbol. So the next step would be 2, because we have to follow BEDMAS. We have to multiply 3 by 5 first. So 2 plus 15. And lastly, 2 plus 15 gives us 17. The next example, 3 minus 2x. Same thing, we're going to plug in the value of 5 in for our x. So we have 3, take away 2, and because there's no operation between those, it's multiplication, so 2 times 5. Equals 3, we have to do our multiplication first because of BEDMAS, So negative 2 times 5 gives us negative 10. And 3 take away 10 gives us negative 7. And you can think about this by using a number line if that's something you're comfortable with, or you can use a calculator, or you can use some mental math, whichever method works for you to get to the correct answer. The next example, 3x squared. I'm going to substitute in my value for x, which is 5. So I've just put in my 5 in brackets because this is multiplication. BEDMAS tells us I need to do my brackets first. So I have 3 times 5 squared, and 5 squared is the same as 5 times 5, which is 25. And lastly, multiplication, so 3 times 25 is 75. In part D, I have 3x bracket squared. So I'm going to take, and this time I'm going to use some square brackets to represent my outside brackets in this case so that I can use brackets within my question inside. So I have 3 times 5, close my square bracket, and then square that. So I'm going to do what's inside of my square brackets first. So I'm going to do 3 times 5, which is 15, squared. And I can use my calculator to work out 15 squared. So remember, 15 squared is 15 times 15. This isn't something that I expect you to do in your head, but the more times you do it, you might find that you do know the answer to this. So this is 225. And the last example is 3 minus x squared. So I'm going to do my 3, take away, and then instead of x, I'm entering in a 5 squared. So I have to do what's inside of my brackets first. 3 take away 5 is negative 2. And negative 2 squared is negative 2 times negative 2, which gives us positive 4, because 2 negative numbers multiplied by each other gives us a positive value as my final answer. Sometimes you'll be asked to substitute in more than one value for the different variables. So in this set of examples, we have a value for x, y, and z, and we're going to see what those look like in a variety of different examples. So for part A, my value for x is negative 2 plus, and my value for y is negative 3. So I'm going to put that negative 3 inside of a bracket for now. And if you remember when we looked at integers in the last unit, if I have two operations or two signs right beside each other, where one is inside of a bracket and the other is outside of the bracket, I want to think about how I can simplify those operations. So this becomes, because I have a plus sign and a negative sign, it becomes a negative 3. So I have negative 2 take away 3, which gives us negative 5 as my final answer. For part B, my value for y is negative 3. This time I'm taking away the value for x. My value for x is negative 2. Same thing, I want to eliminate any extra signs. So I have negative 3 plus 2, because 2 negatives make a positive. And negative 3 plus 2 gives us negative 1 as our final answer. In part 3, I have z, x, y. Because there is no operation between all of these letters, it's multiplication. So I'm going to take my value for z, which is 2, my value for x, which is negative 2, and my value for y, which is negative 3, and I'm placing those all in brackets to show that I'm multiplying those three numbers together. I can do this in one full sweep if I want to, or I can break it up. So 2 times negative 2 is negative 4, and negative 4 times negative 3 is positive 12. So if you need to show your steps, you can. If you wanted to do this all in your calculator to give you the final answer of 12, that's fine as well. For part D, I have 3x minus 4y. 3 times x, which is negative 2, take away 4, times y, which is negative 3. I really want to pay attention and look at BEDMAS, so I have to do my multiplications first before I can do my subtraction or my addition. So 3 times negative 2 is negative 6. Negative 4 times negative 3 is positive 12. So I can do both of my multiplications in one step. And lastly, I want to take negative 6 plus 12, which gives me positive 6. For part E, I have 6x divided by y. So in this question, I'm going to use fractions to represent my division. So I have 6 times x, or 6 times negative 2, and I'm dividing that by y, which is negative 3. So I'm going to simplify my numerator first. So 6 times negative 2 gives me negative 12, and I'm dividing that by negative 3. And negative 12 divided by negative 3 is positive 4. And I can do that by thinking about how many times does negative 3 go into negative 12, or I can use a calculator to get that answer. And lastly, in this set of examples, part F, I have x, y inside a bracket, and then to the power of z. So I have inside of my bracket, which I'm going to turn into a square bracket again, I have negative 2 times negative 3, and this is all to the power of z, which happens to be 2. So I have to solve what's inside of my brackets first. So I have negative 2 times negative 3, which gives me positive 6, and positive 6 squared is the same as 6 times 6, or 36.